All right, picture this for a second. What if your computer knew what you wanted before you even fully did? I'm not talking about guessing, but actually understanding what you're trying to do without you ever clicking a mouse, typing a single letter, or even really forming a conscious thought. I know, it sounds like something straight out of sci-fi, right? Well, that's the core idea behind the amazing technology we're going to break down today. But let's start with a problem we all know. You've been there. You get this flash of insight, this complex idea pops into your head, and then you have to somehow translate that brilliant, fast-moving thought into the clunky language of a computer. It's like trying to describe a beautiful painting using only Morse code. It just feels slow. And this slide just nails the problem, doesn't it? On one side, you've got your brain, fast, creative, nuanced. And on the other side, clicks, keystrokes, taps. That massive gap between the richness of our thoughts and the simplicity of our inputs. Researchers call that the communication bottleneck. It's the real reason why using our tech can sometimes feel like we're wading through mud. So the big question is, how do we break through that bottleneck? Well, what if we flipped the script entirely? What if instead of us always having to learn the machine's language, the machine could start learning ours? And I don't mean English or Spanish. I mean the language of the brain itself. And that opens the door to a totally mind-bending idea, an implicit conversation. This brings us to the hero of our story today, neuroadaptive technology. Now, the key word here, the one you really got to remember, is adapt. This is not about you sitting there concentrating and trying to control a computer with your mind like some kind of Jedi. No, this is about the computer quietly monitoring your natural brain activity and changing itself to better suit what you need. It's creating a shared understanding. So how does it do that? Well, that's what's so wild about it. It works through something called a passive brain-computer interface, or PBCI. And that word, passive, is everything. I mean it. The system isn't waiting for you to send it a command. It's just listening in on the automatic background chatter your brain produces all day, every day, whether you know it or not. Okay, so this all sounds amazing in theory, but does it actually work? Can a computer really learn what you want just by listening to your brain's background noise? Well, to find out, some researchers designed this truly brilliant experiment. Let's walk through it. So here's how it went down. People put on an EEG cap, one of those things that reads brainwaves, and looked at a grid on a screen. On that grid, there was a cursor and a target. In each trial, which was only a few seconds long, the cursor would make one random move. The person's only job was to mentally decide, was that a good move or a bad move, and then press a button. But the whole time, the computer was listening to their brain's instant gut reaction. But, and this is the absolute kicker, here's the big reveal. The participants thought their button presses were what was guiding the cursor. They weren't. The computer logged their button presses, sure, but it completely ignored them. The only thing the computer used to decide where to move next was the raw brainwave data it picked up in the split second right after each move. Okay, wait a minute. How is that even possible? How can a computer learn your goal from a signal you don't even know you're producing? Well, it all comes down to this really powerful automatic signal our brains create whenever they're surprised. You see, our brains are never really off. As the researchers put it, they're constantly and automatically processing everything that's going on. It's not something you have to try to do, it's just the default setting for being human. And the science behind this is a concept called predictive coding. It sounds complicated, but it's pretty simple. Your brain is basically a prediction machine. It's always guessing what's going to happen next. You know when you're walking downstairs in the dark and you think there's one more step, but there isn't? That jolt you feel? That's it. That's a massive prediction error signal. Your brain expected one thing, got another, and it fired off an alert. And that is the secret sauce right here. In the experiment, when the cursor moved towards the target, it matched the user's prediction. Brain says, yep, that's what I thought. Everything's calm. But when the cursor moved away from the target, bam, that violates the prediction. The brain goes, whoa, wait, that's not right, and fires off that big detectable error signal. And the more wrong the move was, the stronger that signal got. So the theory is super cool, but did it actually work? Could the computer really piece together all these tiny whoops signals to figure out the user's hidden goal and actually get the cursor to the target? Well, let's look at the results. All right, check this out. On a standard 4x4 grid, a completely random cursor took about 27 moves to find the target. A simulated, perfect cursor that knew the goal took 10 moves. And the neuroadaptive cursor, the one guided only by those passive brain signals, it took just 13 moves. I mean, come on, that is almost perfect. But they didn't stop there. They threw it a curveball, a much harder 6x6 grid that the system had never even been trained on. Now, a random cursor here took a staggering 90 moves. The perfect one took 14. And our brainwave-guided cursor, get this, just 23. It learned the goal and adapted to a brand new environment totally on the fly. Let me just boil all this down to one incredible number. On that harder grid, the system closed 88% of the performance gap between pure chance and absolute perfection. That's just an astonishing level of success for a system that's running on nothing but implicit brain signals. So let's just let that sink in for a moment. The computer successfully built a model of what the user wanted to do. It learned their goal without a single conscious command, based entirely on their brain's automatic unconscious reactions. Look, this was never really about moving a cursor on a screen, right? This experiment proved a fundamental principle. It's a proof of concept that could kick open the door to a completely new way of interacting with all kinds of technology in our lives. So where could this go? I mean, just let your imagination run wild. Imagine interactive stories that change based on your real, gut-level emotional responses. Or software that senses you're getting frustrated and offers help before you even think to ask. Think about cars or planes that could detect if a pilot is getting overwhelmed or confused. The possibilities are huge. Of course, this is where we have to pump the brakes a little. This incredible potential also raises some really big, important questions, and the researchers themselves were the first to bring them up. When a system can read our automatic, even our unconscious responses, how do we make absolutely sure the user is always in control? That's a critical challenge we have to solve as this tech moves forward. And that leaves us with one final provocative thought to chew on. For all of human history, we've had to be the ones to adapt to our tools. We learn their rules, their logic. But what happens to us and our world when for the first time ever, our tools start to adapt to us? What changes when our technology can understand us implicitly,